Well, welcome back everyone to another exciting JLand Bio video. My name is JLand Bio, and today we are going to continue our work in motion by talking about several different concepts related to physics. In particular, we're going to be looking at acceleration and forces today. So, by the end of this video, you should be able to define and calculate acceleration. We're also going to talk a little bit about what forces are, describe and define friction, and then understand fundamentals of gravity and weight. So, perhaps you've noticed through your schooling that it is more difficult to lift a book bag containing 3 books than it does to lift one with just 1 book. Well, why is that the case? I mean, obviously we understand that there is more mass in 3 books than there is 1 book. There is more weight. But how does that have an impact on how much force is needed to change an object's motion? So we're going to dive into those concepts a little bit later in the video. Acceleration is just simply the rate of the change of velocity. Now, you know last time we talked about velocity and speed and how they're similar and how they are different, but acceleration is the rate at which velocity changes. You feel this when you're in a car that's all of a sudden speeding up, that feeling that kind of throws your body into the back of the seat. That's the acceleration of the car. You don't feel that when the car is at a constant velocity because there is no acceleration. It's the same thing when somebody brakes. You feel, it kind of jerks your body forward. That's the deceleration of the car changing velocity. It's the same thing in an airplane. If you've ever flown in an airplane before, right before takeoff, you're moving at a very slow velocity, and then all of a sudden the engines kick on and you're kind of thrown back in your seat a little bit. Again, that is due to the concept of acceleration. That is because the velocity of the object, of the airplane itself, is changing. Acceleration that is positive means that the rate of velocity increases, and if it is decelerating, then the rate of velocity decreases. So a speed time graph is very helpful in determining whether an object is accelerating, decelerating, or has no acceleration. So if we take a look at the right-hand side graph here, we have positive acceleration at the very beginning of the graph because the velocity is increasing over a period of about 4 seconds. As the velocity remains constant in the next part of the graph, there is 0 acceleration, so you see that the line is flat, or there is no slope if you're talking in terms of mathematics. And then the last part, for the last 3 seconds, the velocity decreases from 8 meters per second to 0. That means that we are decelerating or accelerating in the opposite direction of the velocity, and as a result, we end up losing velocity until we have none. Calculating acceleration is very easy. Remember, it's just the change in velocity over time. So acceleration is going to be the final velocity minus the initial velocity divided by time. Now again, this value can be positive or negative if we are accelerating or increasing the speed in the rate of direction that we are going, or decelerating or decreasing the speed in the rate of the direction we are going. A skateboarder has an initial velocity of 3 meters per second west and comes to a stop in 2 seconds. What is the skateboarder's acceleration? Well, remember that acceleration is your final velocity minus your initial velocity over time. We have initial velocity of 3 meters per second, and if we come to a stop, that means that our final velocity is going to be 0 meters per second. And it comes to a stop in 2 seconds, so we can just plug in our numbers and solve. Our final velocity is 0 meters per second. We're going to subtract 3 meters per second, and that takes place over 2 seconds. We plug those numbers into our calculator, and what we get is negative 1.66. Now the unit for this is actually going to be meters per second squared. So that tells us a little bit of information, right? The negative sign here tells us that we are decelerating. All right, so pretty straightforward on how to go through and calculate these things, but remember, make sure to keep in mind your final versus your initial, as well as being able to plug in time to solve for acceleration. I may ask you to do other things to be able to solve for some other variables as you plug in these types of equations. Centripetal acceleration is very interesting. It is the acceleration towards the center of a curved or particular path. This, interestingly enough, describes a little bit about planetary motion, that there is a force that is drawn into the center as an object orbits around it. This is one of the reasons why the moon revolves around the Earth, is due to some centripetal acceleration due to a force known as gravity. We'll talk more about that a little bit later on. Also consider projectile motion. Consider when you throw or shoot a rubber band. The velocity of the rubber band causes it to move horizontally, but you know that that rubber band eventually falls to the earth. In a path that is gravity-free, that particular rubber band is just going to shoot and continue to move until it hits a wall, or, well, it may just go on forever. But we know that gravity plays a role in this. And so as the rubber band moves, it starts losing horizontal velocity and gaining vertical velocity, meaning that that object starts increasing velocity towards the earth. Well, why is that the case? Well, that is due to the acceleration due to gravity. On Earth, it's 9.8 meters per second squared. On other planets, gravity has a different role. Gravity is directly related to the mass of the object. So gravity is about 1/6 of what it is on Earth when you compare it to the moon. So you'd have a weight that is 1/6 of your normal weight on the moon. Let's talk a little bit about forces. A force is just simply a push or pull and can cause the change of the motion of an object. The net force is the sum of all forces acting on an object. So here we have some examples. Now N stands for Newton, which is just a unit that we use for force. So if we look at A, we have 2 newtons being pulled to the left and 8 to the right. So what would the net force be acting on the object? Well, there's 8 newtons going to the right and 2 to the left, so the net force is going to be 6 newtons to the right. On B, if you take a look here, we have 2 forces acting in the same direction, so you would add them together. 10 and 2 make 12. So on B, we have a net force of 12 newtons acting on the right-hand side. On C here, we have 8 newtons acting on the left and 8 on the right. Well, if 2 objects, just like I think of tug of war, if we have 2 objects or 2 individuals with the same amount of force pulling on an object, the object is not going to go anywhere. So there is no net force on that particular object. So keep kind of these things in mind as we take a look at forces and start thinking about how the individual forces can add up to equal the net force of an object. So for example, in A, we're going to get some movement to the right. B, again, movement to the right. C, no movement at all. And D, again, you add up the forces. We have 10 on the left, 8 on the right. So we're going to have a net movement of 2 newtons to the left. Now, friction is a force that opposes the sliding motion of 2 surfaces that are touching each other. You probably know some concepts of friction. You know that ice has very little friction, which makes it more difficult to stop when you're walking on it as opposed to, say, like a sidewalk, or let's say if you're walking on sandpaper. There are several different types of friction. The first one is static friction, where it's the friction of the object that's static. It's just sitting on a surface. You know that you have to push an object with a certain amount of force in order to overcome the static friction. That is, to be able to move the object from its initial resting point. As you continue to push, you get what's called sliding friction. So if I continue to push the object and then stop, sliding friction is then going to stop the object from moving. It's not as if I were to just push the object and once I get it to a certain velocity or a certain force, that eventually it is going to continue going on forever. Eventually it will stop, and sliding friction causes that to happen. And lastly, we have rolling motion and rolling friction. And rolling friction is actually quite beneficial. It's an example of a tire. A tire actually has certain friction with the surface, and that kind of grips the surface, allowing for the rolling motion to occur in the opposite direction. It kind of gives it a little bit of a push, so to speak. So all these different types of friction play a huge role in being able to move objects and understand the concept of forces. Now, gravity is an attractive force between 2 objects that depends on the mass of the object and the distance. Again, we focus on mass of an object. I think I mentioned previously the moon versus the earth. The weight of an object on Earth is 6 times that on the moon. That is because the moon is 1/6 the size of Earth. That is because the moon has a smaller mass than Earth. Objects with larger mass have more gravity. Keep in mind that all objects have gravity. I even have gravity, but my mass is so small when compared that to the Earth or moon that my gravity is negligible. It also has to do with the distance as well. The moon orbits around the Earth because it is close to the Earth and therefore feels the effects of gravity from the Earth. The moon does not feel as much gravity from the sun, which is why the moon does not orbit the sun. The moon orbits the Earth because of the distance that the moon is away from the Earth is much less than that of the moon and the sun. So you just need to keep these things in mind, that mass and distance play a huge role in whether an object would feel the forces of gravity or not. Let's talk about weight for just a second. Weight is the gravitational force exerted on an object. So while we think about weight is kind of in terms of mass, it's actually has to do with the gravitational force exerted on an object. My weight on Earth is going to be very different than my weight on the moon. Weight is just simply mass times gravitational acceleration. And on Earth, acceleration is 9.8 meters per second squared. So you would just be able to plug these numbers in and solve very easily for the weight of an object. A squirrel has a mass of 0.5 kilogram. What is its weight? Well, if we remember our formula, our weight is equal to mass times acceleration. Okay. We remember that acceleration due to the Earth is 9.8 meters per second squared. So we can solve for weight very easily. We would just say that our weight is equal to 0.5 times 9.8. We do our math, we get our weight to be 4.9, and the unit for weight for our class is going to be N, which stands for Newton. Okay, and if you want to break down that unit even further, it would be kilograms times meters over second squared. But again, not a huge deal here, so just make sure you're able to plug in those numbers and solve very easily for those problems. So hopefully this video is pretty straightforward. Your goals here are to be able to define and calculate acceleration. You should be able to explain a variety of different forces, define and describe friction, including static, rolling, and sliding, and then also be able to understand fundamentals of gravity and weight. Hopefully, again, pretty straightforward video. Make sure you like, comment, and subscribe. If you have any questions, let me know, and we will talk to you guys later. Have a great day, everyone. Bye-bye.